In this video, we're going to talk about linear versus nonlinear functions. So what is a linear function? Well, it's basically just a straight line, but it has to have the same slope or rate of change throughout the entire line. So it's constant rate of change is what we call it. Our equation can be in a lot of different forms. So look at some examples here of what's a linear function versus nonlinear from a graph table and equation. So from a graph, it's pretty simple and straightforward. We're looking for something that has a straight line all the way through, no curve. So this obviously is not a linear function. These all are straight lines, but notice this one is just a segment. It stops on both ends, whereas these two go forever. So these two are linear functions. We can't say that a segment is a linear function. It can be part of a linear function that has a restricted domain or range, but it wouldn't be considered linear function. Notice that these can be vertical, horizontal, or diagonal. From a table, all we have to do is check the slope from one point to the next. If it's the same, then it tells us that it is a constant rate of change and it would be linear. So in this case, our x values from here to here goes up 1, and then from here to here goes up 3. So this is a slope from this point to this point of 3, and I need to find that for all of the rest of the points. Notice how we continue to go up by 1 from each point, or from each x value, and then our y values continue to go up by 3 as well. So our slope from one point to the next is 3 over 1. Be careful if the change is not the same throughout your x values, because this could be a jump from 2 to 4, and these are all plus 3, and at quick glance we might miss that and see that this actually wouldn't be a constant rate of change between these last 2 points. So notice how if we just change that one value there, we've got a slope of 3 over 1 from here to here, and from here to here, but then from here to here it's a slope of 3 over 2. In this example, again, we go up by 1 for each of our x values, and so it must be the same over here, but we're going up by a different amount, so the slope is different from one point to the next. Last example is equations. There's a lot of different equations that would work for a linear function. It has to include x, y, or both x and y. Remember, if you see f of x equals, that's the same as y equals. The other big thing we look for is the exponent for our variables, for x and y. We have to have positive integers there. So notice how all these examples here, there's different forms. These three all have x and y. These each just have 1, but they're all just x or y to the first power. There's no exponent shown, so it's just to the power of 1. But x squared, square root of x, if x or y is in the denominator, if we have a negative exponent, or if they're being multiplied, all those are examples of nonlinear functions.